privilege to welcome you to the 4th International Conference on Advances in Mechanical Engineering and Material Science, ICAM-2026, organized by the School of Mechanical Engineering in collaboration with Auckland University of Technology, New Zealand, and Robert Gordon University, UK. We are honored by your presence and we gather here today to celebrate the innovation, research and global academic collaboration. To formally begin this international conference, I invite Dr. Ambud Sharma, co-convener of ICAM-2026, to deliver the welcome address and initiate the proceedings. Sir.
Good morning all. Good morning to all respected guests, respected deans, directors, section head, esteemed faculty members, dear participants and students. It's given me immense pleasure to welcome you all for 4th International Conference on Advances in Mechanical Engineering and Material Science, ICAM-2026. Organized by School of Mechanical Engineering, VIT-AP University, in collaboration with Auckland University of Technology, New Zealand, and Robert Gordon University, UK. I feel truly honored to extend a warm welcome to our chief guest, Mr. Anjan Kumar Panda, sir, Principal Consultant, Turbo Machinery and Plant Engineering, Infosys Limited, Mysore. We are equally privileged to have with us our guest of honor, Dr. Sur Narayana J, Professor, IIT Hyderabad, and co-chairman of IEEE Nanotechnology Hyderabad chapter. We are grateful to warmly welcome our esteemed Vice Chancellor, sir, Dr. P. Arul Moji Barban, whose continuous support and guidance have been a pillar of strength in organizing this conference. So we also extend our sincere welcome to our convener, Dr. Dilip Kumar Mohanty, Dean School of Mechanical Engineering, VIT-AP University, Dr. Sarath Singnanemi, Professor, Auckland University of Technology, New Zealand, and Dr. Sohail Akhtar, School of Mechanical Engineering, Robert Gordon University, UK. As per the schedule, I will request all dignitaries to come on the desk and lighting the lamp. Kindly, sir.
May I now request our esteemed dignitaries to kindly come forward to lighting of the lamp. Thank you, sir. Thank you, everyone. May this slide guide us towards meaningful discussions and discoveries today. Now, to provide an overview to ICAM EMS-2026, I invite Dr. Dilip Kumar Mohanty, the convener of ICAM EMS, to address the gathering. Sir.
A very good morning to all of you, dignitaries on the dais and off the dais. Honorable Vice Chancellor Professor P. Arul Moli Barman, Registrar Professor Jagdish Chandra Muriganti, Chief Guest of the event today Mr. Anjan Kumar Panda, Guest of Honor Dr. Surya Narayan J, Convener from Auckland University of Technology Dr. Sarath Singanani, Convener from Robert Gordon University UK Dr. Suhail Attar, Co-convener Dr. Ambuj Sharma, Deans, Directors, Faculty colleagues, Research scholars, participants both in online and offline mode, and my dear students. A warm and hearty welcome to everyone attending the 4th International Conference on Advances in Mechanical Engineering and Material Science, ICAM EMS 2026. It is a great honor and I feel myself quite privileged to be here to give the information address about our 4th edition of our conference by the School of Mechanical Engineering, that is ICAM EMS 2026. I am quite thrilled to see such a diverse and distinguished gathering of experts from across the globe. VIT has continuously developed a spectacular level and height of academics and research, not only in our nation, across the globe. In this regard, the VIT-AP University has been a front runner in delivering quality education with a vision of creating one of the most significant destinations in the world. The School of Mechanical Engineering is one of the founding schools of VIT-AP University since its inception in 2017. The primary objective of the school is to impart knowledge-centered education and mold the young minds into the future engineers in order to meet global challenges in the area of mechanical engineering. In the recent years, SMEC has produced very high-quality engineers to carry forward the nation one step ahead towards the highly industrialized and technologically advanced modern world. The school offers undergraduate program in core mechanical engineering with specialization in automotive design, and mechanical engineering with specialization in robotics. Besides, the school offers research program leading to the PhD degree. The school provides world-class laboratories, facilities at par with the modern-day cutting-edge technologies in the area of advanced manufacturing, robotics, material characterization, and thermofluids. On this path of excellence, this conference series ICAM EMS put up its initial step in the year 2022 to provide a platform for the eminent researchers in mechanical engineering and material science. Over the past 4 years, we have conducted 3 conferences in this series, and this is the 4th edition of our conference series, ICAM EMS. And the 4th edition of this conference is a testament to our commitment to pushing the boundaries of knowledge and creating platforms for meaningful dialogue. This edition of the conference is organized in collaboration with the Robert Gordon University, UK, and the Auckland University of Technology, Auckland, New Zealand. In this edition, a total of 189 participants participated and submitted their research outcome for further process of presentation and publication. Out of that, 76 participants were accepted for presentation of their research outcomes and further process. I am extremely glad to inform you all that 4 eminent journals have agreed to publish the presentations of our conference and these journals include Thermal Engineering and Sigma Journal of Engineering. Both are ESCI indexed, and then Scopus Index Journal, Interactions, and the Journal of Applied Material Science. So this conference is going to continue for the next 2 days, spanning from 22 to 23. Over the next 2 days, we are going to witness a series of enlightening sessions, thought-provoking discussions, and groundbreaking presentations that promise to leave a lasting impact on our academic community. I would like to extend my heartfelt gratitude to our distinguished guests, keynote speakers, participants for joining us. I am sure that your presence today signifies the importance of the collective effort we are making to advance our understandings and capabilities in this domain through this conference. Whether it is the thermal science, fluid behavior, heat transfer, product design, high-performance computing, advanced machining, or Industry 4.0, the insights and solutions we develop here will shape the future of our field and society at large. I would like to encourage each one of you to make the most of this conference and the keynote sessions and the discussions, which can give a very good platform for discussions and putting your ideas for the future technology. So with this, I once again welcome you all to this conference, ICAM EMS. Thank you.
Thank you, sir, for that insightful introduction. Now I invite Dr. Sarit Singamneni, convener of Auckland University of Technology, New Zealand, to share his thoughts. Sir will be sharing his thoughts through the virtual format. Can we please have our attention on the display screen? Thank you. Please give a round of applause to Dr. Sarit Singamneni. Over to you, sir.
All right. Can you hear me?
Yes. Yeah, no mic.
Can you hear me?
Yes.
Yes, sir, we can hear you.
All right. Thank you very much. Good morning. Though it is almost evening here in New Zealand, the time is 4:53 p.m., almost 5 p.m. We are getting into winter gradually in the southern hemisphere. The darkness is gathering outside, and as we progress more and more into the winter, the days become shorter and shorter, and by now it would be almost total darkness in a few days. And also it's getting very cold over here. I am Sarat Singamneni, I'm a professor in mechanical engineering and also the director of the Smart Systems, Materials and Manufacturing Research Center at the Auckland University of Technology, New Zealand, commonly known as AUT. It is a privilege to represent AUT as a co-host of this international conference on advances in mechanical engineering and material science. My sincere appreciation to VIT-AP University, particularly the School of Mechanical Engineering, for organizing this conference.
Sir, sorry to interrupt, sir, but it seems that your voice is not very clear. Could you just increase the audio a little bit? Because here we are not receiving the audio very loud. It's slightly low, low pitched. So even now the pitch is a little low.
Just 1 second.
If you could increase the volume, sir, a little bit.
I can't do that. I don't know. It is already in full volume.
Okay, fine.
I don't know.
This is fine, sir. Yeah, this would do. Thank you, sir.
Is it okay?
Yes, sir. Now it's fine. Thank you.
All right. All right. Sorry for that. So, okay, I'll continue with that. My sincere appreciation to VIT-AP University, particularly the School of Mechanical Engineering, for organizing this conference. The collaboration with Robert Gordon University, UK, is also of great value. Research that leads to real-world impact is what matters today. And strong international collaborations, shared expertise, and global perspectives are essential to achieve this. At Auckland University of Technology, and through the Smart Systems Materials and Manufacturing Research Center, we are committed to applied research, industry collaborations, and innovation-led solutions. Our work focuses on areas such as advanced manufacturing, smart materials, additive manufacturing, and digital engineering systems, with a strong emphasis on translating research into real-world impact and a central theme to bring industry and academia together. Our involvement in this conference reflects our university's commitment to building meaningful global partnerships and supporting knowledge exchange. The themes of this conference are very relevant and quite timely. Mechanical engineering and material science are evolving rapidly, driven by sustainability needs, digital technologies, and the demand for smarter and more resilient systems through adaptive implementation of the emerging AI technologies. I believe this conference provides the excellent platform to explore these developments. I would especially encourage students and early career researchers to actively engage, ask questions, share ideas, and build connections. I congratulate the organizing team for bringing together participants from such diverse backgrounds. On behalf of AUT, I wish you all a productive and engaging conference. Thank you, and thank you very much.
Thank you, sir. It is now time to introduce our esteemed guest of honor, Dr. Surya Narayana Jalamamadaka. Dr. Surya Narayana is a distinguished professor at IIT Hyderabad with a PhD from IIT Madras and recipient of the prestigious Professor A.L. Lasker Award. His research spans cutting-edge areas such as spin electronics, neuromorphic computing, and optoelectronics. With over 80 high patent publications, multiple patents and fellowships, including FRSC and IEE senior membership, his contributions to science and technology are truly remarkable. Ladies and gentlemen, boys and girls, please put your hands together for Dr. Surya Narayana.
So very good morning to everyone. Yeah. So first of all, dignitaries, respected dignitaries, director, and then the conference organizers, and my dear participants. It gives me great pleasure to stand in front of you to be as a guest of honor for this conference and on the international conference on mechanical engineering and material sciences. As you know that the mechanical engineering, it's about design and then developing new technologies, and material science would give the new materials with high strengths and with different physical properties. So I am sure that without mechanical engineering and material science, it is almost impossible to develop any technology. If you look at the history, in the olden ages, people were trying to use the stones and bronze materials for the development of tools and all. Later, the steam engine, the invention of the steam engine has revolutionized the industry, and because of which the motor vehicles have started, and then later in 20th century, the lightweight material research has been started, and which allowed us to have the aviation technology, aeroplanes and all. Okay, so we are at the verge of the artificial intelligence and quantum technology. The mechanical engineering and material science would play an important role for the development of these technologies. For instance, if we take artificial intelligence devices, which generates a lot of power to reduce or to heat, these artificial intelligence devices will develop a lot of heat. So we need to reduce the heat that is generated by the devices. Certainly, the cryogenic technology that we try to develop using the mechanical engineers will be very much useful. On the other hand, if you look at the quantum technology, that is one of the emerging technology that is evolving, so which basically does the quantum computation. So if you want to do the quantum computation, what you need to do is you need to take your system to very low temperatures, millikelvin temperatures. This is where the mechanical engineering would give lot of inputs, in the sense that cryogenic technology that you try to develop will be very much useful to take to the low temperatures. On the other hand, the vibration free tables are very, very important. So if you look at the quantum computer, the qubits are used. These qubits will be at very low temperatures. Even a small disturbance or maybe the small perturbation that comes from the ground or somewhere will try to kill the quantum state of the qubit. That's the reason why the high sensitive anti-vibration tables are very, very important for the quantum computation applications. And then the cryogenic technology, it is very, very important. And all these things will put together, one can develop these quantum computers. It is not only restricted to the quantum technology, quantum computing, like we also have other verticals in the quantum communication, then quantum sensors, then quantum materials. In whatever aspects that you see, the mechanical engineers and then material scientists would play a major role. Okay, so for instance, if we take the composites or maybe the lightweight materials, which will be very much useful for many, many technologies like aeroplanes and so on. Right now, so much of research is going in the direction of composites and lightweight materials. Then the biotechnology also, the material science would play a major role, and in the medicinal technology, then the robotics arms, the robotics, these things would play a major role. For instance, if we take the magnetic hyperthermia applications, the material scientists would play a major role in sending the drugs from one part to the another part, or otherwise if you want to kill the cancer cells, you need to use the magnetic hyperthermia. That's where the development of materials for such kind of the medicinal treatments, the material scientists would play a major role. Then apart from this, like the sensors, for the sensors also, the mechanical engineers and material scientists would play a major role. I'm very happy to say that during my PhD topic was in collaboration with mechanical engineering. My major topic is in physics, and then some part is from the mechanical engineering, NDT, non-destructive testing at IIT Madras. In the physics, we had to develop the material and study the characteristics. In the mechanical engineering, I had to develop a transducer, magnetostrictive transducer for the non-destructive testing applications of various materials. Okay. So apart from that, the piezoelectric materials, which would be energy efficient materials, like which can generate the high frequency, and those things can also generate ultrasonic waves. So basically, the magnetostrictive materials and then piezoelectric materials development will be done by the material scientists, and then developing a transducer and designing a transducer will be done by the mechanical engineering. In whatever technology that you see, in whatever aspects that you see, starting from the artificial intelligence to the quantum technology, the mechanical engineers and then material scientists would play a major role. So my dear participants, it is the future technology. It is not just magic. It is basically the machines and materials. So we would require the innovation in the mechanical engineering and material science. If you do the conventional things, nothing will evolve. Like innovative technologies must be developed, innovative way of doing the things, innovative way of doing everything. Like that's what I tell to my students all the time. If you want to be recognized, you must be something special. You cannot do the conventional things. You must think out of the box. out of the box and try to get new ideas, start implementing these new ideas in the existing technologies so that you will be recognized. Don't go in the way of the people where they go. You try to be on the other side. You go in other direction so that people will recognize you. That is one of the important aspect to be recognized. Okay. So the material scientists and then mechanical engineers are very, very important. They are not only important, they are indispensable for the country. The material scientists and the mechanical engineers, like the nurturing these fields in the institutions is very, very important. It will not only develop the fields in the institutions, but it will also develop the technologies for the human in future. Okay. So my dear participants, with this, I believe that all of you would try to be innovative and creative in developing these technologies using the concepts of the mechanical engineering and material scientists, so that you will contribute towards the Atmanirbhar Bharat and Make in India programs. So I believe that in future we will be able to see that the Make in India product in the foreigners should be able to purchase Make in India product. So that is the real success that we would like to envisage. With this, I believe that you will try to learn more and more things in this conference. I am sure that you will be benefited by this conference through the networking. Again, another point for the young minds, for the students, I would like to emphasize that the networking is very, very important among the research scholars, and then networking between the faculty and research scholars is also very, very important. Try to discuss with the people. Don't sit alone at one side and don't try to discuss among your own people. Try to meet new people, try to do good networking so that your communication skills will increase and then ideas will transfer. So Dr. Mohanty, he has created this good platform where you can do very good networking and you can discuss all aspects related with the mechanical engineering and material science. So I congratulate everyone, particularly Dr. Mohanty and then Director Sir, and then I wish all the best for this conference. Thank you very much.
Thank you, sir, for that enlightening and thought-provoking address on telling us how material science and mechanical engineering is advancing in the 21st century. Now, I invite our Honorable Vice Chancellor, Dr. P. Arunmuri Marban, to kindly address the august gathering. Sir.
Very good morning to all. Good morning. My dear students, distinguished guests, esteemed academicians, industry leaders, researchers, very good morning to all of you. The best way to predict the future is to create it. So, by the Peter Drucker, the powerful thought perfectly reflects the spirit of the innovation and the inquiry that defines the 4th International Conference on Advances in the Mechanical Engineering and the Material Science, ICAM EMS-2026. It gives me a great privilege and the honor and welcome all of you for this, the 4th International Conference on the Advances in the Mechanical Engineering and the Material Sciences, hosted by the VIT University. This conference it's the 4th edition, stands as a testament of our the sustained commitment to the advancing the research, innovation, and the global academic collaboration. ICAM EMS is being organized in collaboration with the leading global institutions such as Robert Gordon University and the Auckland University of Technology, bringing together and the international community of the scientists, engineers, and the industry experts. On this special occasion, I thank the Dr. Sarath Singhmani, the convener of the Auckland University Technology, Auckland, New Zealand, yes, just now addressed. Thank you, sir, for your kind presence and addressing the gathering today. Also, we are thankful to Dr. Sugai Lathar, the convener of the Robert Gordon University, Aberdeen, UK. The respected guest of honor, Dr. Suryanarayana J., the co-chairman of the IEEE Nanotechnology Hyderabad chapter, professor and the IIT Hyderabad. Thank you, sir, for your kind presence and the valuable address and enlightened that today's new generation to focus on the sustainable engineering and also Industry 4.0 and the artificial intelligence and the quantum technology and the advanced material that you have addressed. We are also going to hear from the chief guest, Mr. Anjan Kumar Panda, the principal consultant from the Turbo Machinery and Plant Engineering Infosys Limited, Mysore. Thank you, sir, for your kind presence today, and thanks for your the kind acceptance to address today this event. I thank all the organizing team for making this the wonderful arrangement. I thank the Dean, School of Mechanical Engineering, Dr. Dilip Kumar Moganti, and Dr. Ambuj Sharma, the conveners, co-conveners, and Dr. M.V. Ravindra Kumar for their great effort. Friends, today we are living with the time of the unprecedented transformation. You know that even the modern war, when we are looking into that, it's driven by the artificial intelligence, it is driven by the adaptive materials, it is driven by the sustainable engineering and the advanced materials. Mechanical engineering and the material science, it is a backbone, no longer as the traditional disciplines. They are the enablers for all the future. The professor has rightly pointed out, whether being you are the robotics and the automation or the artificial intelligence or the quantum technology or any level of the innovation in the healthcare, this mechanical and the material science play a major role. The power of clean energy system, yes, just pointed out the importance of the power optimization and the energy, okay? So the sustainable technologies, this concept of the material science play a major role. They drive the advanced manufacturing, whatever the concept today we are talking about the additive or the smart manufacturing. The material concept is very, very important for the robotics and the automation. They enable the smart materials, nanotechnology, and the lightweight structures. The mechanical and the material science contributes for all the healthcare innovation, aerospace, and also the mobility solutions. Today, the global challenge is, one is the energy efficiency, climate change, resource scarcity, and the resilient infrastructure, which requires an integrated engineering level of these solutions, not just one discipline alone. Okay, so we must appreciate that the contribution from all the discipline going to play a major role. So no longer we are going to be isolation, we have to work together. That's what the professor has rightly pointed out. You have to identify the other domain people, create the interface, and you need to have the networking. You cannot work in an isolated way or isolated domain. So the essence of this, platform or international conference, it's to bridge the theory and the practices. You can get to know from the vibrant forum like this to sharing the cutting edge research from across the domain, right from the design, manufacturing, thermal and the fluid sciences, and also discussing on the emerging technologies and the interdisciplinary areas and the innovations. So mainly to building the collaboration across all the academia, industry, and the research institutions. Such platform will strengthen and empowering the future engineers and the researchers. I am particularly delighted and the participation of the young researchers and the students here. The conference not just presenting the papers, okay, I request all of you to carefully look at the inspiring the new ideas. The conference might have not demonstrating the complete proven data, but it is a ad hoc results. They are coming and presenting it. And we need to appreciate what are all the inspiring and the new ideas, encouraging the critical thinking, creating the global research network. That's where we are collaborating with the Aberdeen University, UK, and also for the Auckland, New Zealand. I am sure that VIT-AP University, we strongly believe in fostering the research-driven ecosystem that aligns the global needs. This ICAM, which reflects our vision of promoting the cutting-edge research, strengthen the international level of the collaboration, encourage the industry-relevant level of the innovation, and contributing for the societal development through this the mechanical and the materials technology. As we inaugurate this ICAM, I urge all the participants to deeply engage with all our researchers, exchange the ideas freely, collaborate and meaningfully. Let this conference not just be the academic event. We have to ensure that it is a catalyst for the innovation, sustainability, and the global impact. I extend my sincere appreciation to the entire organizing committee, faculty, and our academic partners and the industry partners for making the conference a reality. I wish ICAM a grand success and hope this is a groundbreaking research, meaningful collaboration, and transformative solutions. Thank you. I wish all the productive and the inspiring conference. Thank you all.
Thank you, sir, for your motivating words. It is now my honor to introduce our chief guest, Mr. Anjan Kumar Panda. Mr. Panda is a principal consultant at Infosys with over 25 years of experience in aerospace engineering. His expertise spans aircraft structural design, composite structures, and advanced aero engine technologies. He has worked with globally renowned organizations such as HAL, Airbus, Rolls-Royce, Mitsubishi Aircraft, and General Electric. His vast experience and industry insights make him an inspiring leader in the field. May I now invite Mr. Anjan Panda to deliver the chief guest address. Please put a round of applause for sir.
Good morning. Respected BC sir, respected Dean School of Mechanical Engineering, respected convener, co-convener, guest of honor, all the organizers of the event, and my dear student friends. It's at the outset, I would say it's a great honor for me to share the stage with great researchers. I think you may be wondering why someone from Infosys, which is presumed to be a IT service company, is here. So actually, next year I am going to complete almost 30 years in the industry. So I started with Hindustan Aeronautics Limited in the area of manufacturing and overhauling and design of MiG aircraft engines. So, as you know, every product has different stages. Like, say, it starts with the concept stage, then it moves to the design and development stage, then the manufacturing, then sales and distribution, then services and post services and recycling and all that. So I have the good fortune to get involved in almost all the stages of product development, starting from the concept till the after sales services. So I started my career with overhauling of aircraft engine, especially MiG engine, which is fitted in like MiG aircrafts. So after nearly 10 years of experience in the manufacturing and overhauling and design development and testing in the real world, it was a golden opportunity. Like, as you know, like India, the first defense aircraft that we have manufactured is our LCA, the light combat aircraft. Till now, we have not succeeded in with our Kaveri engine, which was supposed to be fitted in the LCA aircraft. So still we are dependent on General Electric G404 engine is being fitted there. So aircraft engine development is one of the most complex technologies involved in aircraft engine development. So in the process of this getting involved and physically see the MiG engine development, I had got an opportunity to see like how nearly 4,000 to 5,000 components are getting manufactured from the raw material to the finished product, getting assembled and getting tested and sent to the, like say, to the airframe and get fitted there, and then go to the to our Air Force, which is backbone of our defense. Indian Air Force is the backbone of our defense. As you know, like nowadays, it's like how much is the importance of strong Air Force in our recent operations in Durandal, you might have all understood. So then post that, in Infosys, you may be thinking that we are involved mostly into IT services. Say, for example, development of different applications, say banking and financial services, insurance, healthcare, retail, and all that. But in industry, you are all mechanical engineers, so you will be excited to know that in India, there are, out of all the services that we provide, nearly 20% of the services are related to engineering services. So there are a lot of opportunity in the areas of core engineering, in the areas of product development and manufacturing support, like say IoT services, PLM, product life management, and knowledge-based engineering and all that. So, post HL, I had an opportunity to work for General Electric, and then in Infosys, I am serving different clients around the globe, like Boeing, Airbus, and other aero engine manufacturer, those who are into, like say, aero engines of civil aircraft. Like you may be knowing, like the latest aircrafts like A350 and Boeing 787. So these are the two latest aircraft. Sir was talking about composite. So all the earlier days aircraft like A320, A330, those were made of aluminum. So in last nearly 20 years, starting early 2000, the research into composite has got matured, and in Airbus A350 aircraft and Boeing 787 aircraft, almost 60 to 70% by weight of the aircraft or 80% by in terms of volume of the aircraft is made of aerostructure. Aerostructure is made of composite. So why we need to use composite in aircraft? Because in aerospace application, weight saving is one of the most important factor. So the lighter is the aircraft, the less fuel you are burning and lesser is your operating cost. So the research in composite, as you know, like people, those who are doing research in the area, chemistry and polymer, they do the micromechanics area. Whereas those micromechanics as mechanical engineer, how are the loads that are being applied and what are the different failure modes, whether the structure is going to sustain that load or not, those kind of evaluation, the actual testing and computer-aided simulation we do. As a part of providing engineering services solution. So there are like, when we started as mechanical engineer, some 30 years back, mechanical engineering was considered to be one of the royal branch. being a mechanical engineer, you can become an aerospace engineer, because in India those days, other than IITs, there are not many colleges offering aerospace engineering. So aerospace engineering has 4 specializations like aircraft structure, aircraft propulsion, control and guidance, and CFD and aerodynamics. So mechanical engineer, civil engineer, all, and even electrical and electronics engineer have future in aerospace engineering. And as I told, the major players like Boeing and Airbus are the companies, those are making almost 70 to 80% of the civil aircraft in the world. So mechanical engineer have very good opportunity to enter in the field of aerospace and aero engine technology, which are considered to be the most complex. So as the theme of the conference is mechanical engineering and advances in material. So I remember when our professor was teaching us machine design, without the knowledge of the material, you cannot design anything. So like say strength of material, knowledge of mechanics of material, and knowledge of material research and knowledge of materials are 2 inseparable things. So in aerospace, just I will give you 2 examples. For example, the composites is one which is we are using in the aerostructure, and similarly, as you know, in aero engine, and the turbine blade, if you have done your gas turbine, it will have a compressor, it will have a combustion chamber, and it will have a turbine. So turbine entry temperature, the efficiency of the turbine depends on the turbine entry temperature. So over the years, the attempt has been to increase the turbine entry temperature to the extent possible, so that efficiency of the turbine or the fuel consumption goes down. So the turbine blades are subjected to temperature like 2000 Kelvin or so, which is more than the melting point of the material. So in those cases, how to develop efficient material which can withstand such kind of high temperature. So there is lot of research going on in the material development, especially how to develop, like say the turbine blades, the predominant failure mode is creep. So there are certain failure modes like fatigue and creep and all those advanced failure mode. So a material research is very much important. So material research is inseparable from the mechanical engineering and for the product development. So there has been research in the area of development of high temperature resistant material and creep resistant material like turbine blades. There has been, like the Western countries, those who are way ahead of us in terms of material research, they have developed single crystal material and directionally solidified blade, which will have one single crystal with huge creep resistance, which can withstand material beyond 2000 degree Kelvin. So I am not telling that the melting temperature, the temperature is more than the melting temperature, how it is sustaining. There are certain kind of heat resistant coating and better cooling technique so that the metal sees lesser temperature. So so in context of the theme of the conference, the mechanical engineering and material research, what I come across in the industry, the advances in composite and the advances in development of material for aero engine subjected to severe thermal environment. So material research is extremely important. So these are the 2 areas just I wanted to touch upon. So in a industry, other than the product development in IT services, you have other offerings that we are supporting. For example, the product life, PLM, product life cycle management, knowledge-based engineering, and industry 4 solution like industrial IoT, consumer IoT, and others. So these are the areas which are related to your core mechanical engineering where you can contribute. So how to digitize the manufacturing and completely using the IoT sensors and all, how to establish communication between machine to machine, machine to human, so that the maintenance can be more predictive than reactive, and things are all integrated so that we can make use of more and more digitizations. Okay, so in brief, what I would tell from my experience, there is lot for mechanical engineers and core engineers. So other than the computer science related branches, mechanical engineering will always remain the royal branch, because it has been and it will always be. Okay, so try to stay focused in the core engineering. Don't get demotivated that whole world is only IT services. Okay, thank you so much.
Thank you, sir, for sharing the wide array of your experiences. I'm sure students have definitely familiarized themselves with the areas that are upcoming with the vital experiences that you shared with us today. Thank you for that. Now we'd like to take a special moment to thank our chief guest and guest of honor for taking the time for coming today for this event. For this, we start with the felicitation of both our guests, for which I invite our Vice Chancellor to kindly present a token of our appreciation, which is a shawl and memento. First, we'd like to honor our chief guest, Mr. Anjan Kumar Panda. Can we have a round of applause for sir? Now we'd like to felicitate our guest of honor, Dr. Surya Narayana, with a token of our appreciation, a memento and a shawl. I request sir to please present it to our guest, Dr. Surya Narayana. Please have a round of applause for sir. And now we proceed to the inauguration of the conference souvenir. For this, I request our dignitaries to kindly unveil the souvenir for our conference today. Thank you, everyone. This definitely marks as a significant milestone for ICAM EMS-2026 conference. As we approach the conclusion for this inaugural session, I invite Dr. M. V. Raghvendra Kumar, the co-convener at ICAM EMS, to deliver the vote of thanks. Sir.
We would like to express our sincere thanks on the occasion of the inauguration of the 4th International Conference on Advances in Mechanical Engineering and Material Science, ICAM EMS-2026. So we would like to thank our Honorable Chancellor Sir, Vice Chancellor Sir, Registrar Sir, and the entire VIT-AP University management for their continuous guidance and support. We would like to express our gratitude towards our chief guest, Anjan Kumar Panda sir, and guest of honor, Surya Narayana sir, for their valuable presence and inspiring addresses. We also sincerely appreciate our international collaborators, organizing committee, faculty members, and student volunteers for their continuous efforts in making the inaugural session and the conference success. We thank all the participants for their presence. With this, a great respect towards all dignitaries, we would like to conclude the inaugural session of ICAM EMS-2026. Thank you, everyone.
Thank you everyone for being part of the, now we move to the group photograph. For this I invite the entire team to please come on stage for the group photo. May I request the entire school to please come on stage for the group photo. Can we have a round of applause for the entire team, please? Thank you everybody for being part of today's event. Now we move to refreshments for which students can have the